In the past few videos, you can see how useful it is to be able to rearrange formulas. So given a formula, if you wanted to know the time it takes for the cannonball to hit the floor, you could rearrange this formula to make t the subject. So in this case, you have this. Hang on, h equals gt squared over 2. If you want to know t, the time it takes something, you make t the subject. So with one formula, you can rearrange it to make different formulas. So here it will times both sides by 2. It would be this. Okay, divide both sides. So now you would visualize it as this. Divide both sides by g. So it will be this. And then you square root both sides. So it will be this here. T. So from one formula, if you wanted to know t, you could rearrange it to make t the subject. From this same formula, if you're on a mystery planet, and you want to know the gravitational pull of that planet, you could rearrange this same formula to find out the gravitational pull of whatever planet you're on. Suppose you're on a mystery planet, and you know that the height of the building is, let's say, 100 meters. And then you time how long it takes for the ball to hit the ground, let's say 5 seconds. You could rearrange this formula to make g the subject and find out how long, well, you can find out the gravitational pull of the planet. And then that will give you an idea of what planet you're on. So with this one equation here, let's rearrange it to make g the subject. I've shown this before, but I just want to emphasize the usefulness of being able to rearrange formulas. So here times both sides by 2h here, times 2. So this would be this. And now visualize this as one bubble multiplying a bubble here. You want to make g the subject, so kill off this bubble. So divide both sides by t squared. So take the 2h down and then divide it by t squared. That will give you g. So now all you have to do is plug in the height of the building, and then plug in the time it takes to hit the ground, and then you can find out what the gravitational pull of the planets that you're on. See, that's why being able to rearrange formulas is so important, so useful as well. So here, given this formula here, you could actually work out the length of the string. Last time I showed you how to work out the gravity, the gravitational pull of the planet. Now suppose you want to know the length of the string. You know g of what you know g is on the moon is this. You know how long it takes. You can actually work out the length of the string. So all you have to do is rearrange it to make L the subject. So here, imagine here at the moment you've got one bubble multiplying this bubble here. L is stuck in this bubble here. Let's kill off this bubble now. So divide both sides by 2 pi. So take the t down, divided by 2 pi. On this side, it will be root L over g. Okay. Now that square root is annoying. So let's square both sides. So this will become t squared over 4 pi squared. Okay. Because watch one of the earlier videos. I've shown this before. So L over G. Now because you want to make L the subject and L's on top, nice and neat. So let's times both sides by G. So this will be remember when you times a fraction it goes to the top. So this will be this and L. So now you've got yourself a formula for the length of the string. So all you have to do is plug in how long it takes for one period of the swing, and then you plug in g, and don't forget pi is just a number. It's always the same. 3.1 blah blah blah. It's just a number, and then you can find out the length of the string. That's why being able to rearrange formulas is so useful. So in the next few videos, I'm going to show we're going to master rearranging formulas and making something else a subject of this thing, whatever thing you want. So the next few videos we're going to master rearranging formulas.